Assalamu alaikum. In our previous lecture, we were doing mass spectrometry, or sorry, not mass spectrometries. Like HNMR was still so far covered. Now, in HNMR's portion, we did up until HNMR. HNMR was so far covered, and we entered into the mass spectrometry. So from onwards, we'll be dealing with mass spectrometer. So a question was given. So this was the first question of this topic, which was mass spectrometry or mass spectrum. So the question was something like, mass spectrum of a compound A contains M and M plus 1 peaks in the ratio of their heights. Now what does M and M plus 1 means? M and M plus 1 means the, like as they have mentioned here, the number of carbon. It is actually the ratio of, like, how should I explain this? It actually is a ratio which the ratio between, let's say, the height of one peak is given and another height of peak is given, okay, in let's say some graph, and their ratio is given there, okay, it's given here. Now we don't need to know about the peaks of the ratio like in detail, and nothing else is like required in order to know about M and M plus 1. Just know that we can find the number of carbon atoms using this M plus 1 over M, like this formula, okay, and multiplying it with 100 over 1.1, we can get the number of carbon atoms. So this is the formula you have to remember, recall every time. I can't actually completely recall like what is this M plus 1 over M ratio specifically means, like if it has certain value holding into it, but yeah, so for that's the thing. So let's try to solve this question from here. Now, using this formula, the above formula mentioned, what is the number of carbon atoms present here? We can see M plus 1 is to, like, this is M and M plus 1 ratio is given. So that means this ratio is given in which format? See, it says contains M and M plus 1 peaks. So that means the first one is M, the second one is what? M plus 1. M plus 1. But our formula has what? M plus 1 over M. Now, we do know, or if you didn't know, then like now from now on, remember that M is to M plus 1 could also be written as M over M plus 1. Whichever is towards the right side, that goes to the like downside, and whichever is to the left side, that goes to the top side, like topmost part. That means in order to get M plus 1 over M, what do we need to do? We need to just flip the values. So 1 over M plus 1 gives us what? See, it gives us M plus 1 over M. So just flipping the value, trying to find the reciprocal, reciprocating it, we get this value. Okay, so our number of C atoms, how much? From this formula, using this information, we know the formula is 100 over 1.1 times M plus 1 over M, where M plus 1 is given as M plus 1 is our 2.4 and M is our 74. So this is 100 over 1.1 times, remember we just flipped it. So if this was the case at first, 74 divided by 2.4, we need which one? We need 2.4 divided by 74, okay? So that's what we did here. So now 2.4 divided by 74. This will give us an approximate value of 3. Remember this, usually this like calculation would give you some decimal values, but remember number of carbon atoms, it cannot be a decimal or fraction value. It has to be an integer or a whole number. So that's why we are rounding it up to the nearest value, in this case 3. Okay, most probably it should give a value which is close to 3. 2.9 something it might be. So yeah, that's the number of carbon atoms we have. So we now know that our molecule which we are dealing with is going to have 3 C atoms. Okay, now let's use this HNMR chart. So here we can see that there is a singlet over here, there is a quartet over here, and there is a triplet over here. So let's try to find what actually is this molecule. Okay, so the first one, we have how many peaks there? We have 3 peaks. We know how to find the number of H atoms. How? So number of peaks equals to N plus 1, hydrogen plus 1. Then N equals to what? Number of peaks minus 1. So we have 3 minus 1 equals to 2 hydrogen. That means there should be a carbon with 2 hydrogen. Like so far we are thinking. And let's think for this one, which has 4 hydrogens with it. That means this should have N equals to 4 minus 1, which is 3. That means there should also be a carbon with 3 hydrogens. So far our information is saying us. Okay. Now, as we have found there are 3 carbon, there should be another carbon as well. See here we have a singlet near 12, which is greater than 11 but less than 12. Now, remember in our last class we saw the data booklet. Let me try to find it out today again. Let me see if I am able to find the data booklet here. Yes, I've found it. Let me share the screen. I hope the screen is visible in this case. So see, we have certain values. One of them was like we found CH2 where like in the region of somewhere greater than 0. Like this was greater than 0. Greater than 0. Let me write it in this way. That's a CH2. Like CH2 we assume that is greater than 0, less than, it was 2. Then we got something, some information like CH3 sort of in the region of which was greater than 2 and less than 4. Sorry, this should be in the other way. I wrote it in the opposite way. This is 0, this is 2. Yeah. And we also found a peak near 12. Singlet near 12. So singlet near 12. Let's see if we can find anything here at first. Singlet near 12. Here it is 0.9 to 1.7. 0.91 to 1.7. It contains CH2, CH3. Yeah, it is sort of CH2, CH3, like defines our scenario. So it must be our like CH2 group. So this we have. So that means this group we have. Then see about CH3, we're not sure because CH3 isn't in this region. Okay, so that means there should be some other group attached to this CH3. That means there could be a possible, let's say, this could be possible because this is between 3.2 and 4. This could be possible, but still can't say. And also could be possibility that this is this group, like CH3, C double bond O group, but we are not sure. But if this was CH3O group, that means we should have CH3O. But how should we find then our CH2 group? That means CH3 shouldn't be having the part. Let's see. Let's try to find the singlet part here. So the singlet, let's see if we have anything near 11 and like near 12 or more than 11, less than 12. More than 11, less than 12, no. 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 Less than 12, no. More than 11, less than 12. Yeah, it includes the region of more than 11, less than 12. Like greater than 9, like if it is the number line, this is 9, 10, 11, 12, 13. So 9, 10, 11, 12, 13. That means what? It does contain this region. So that means this could be a possible outcome for us. So let's mark this one. So that means it could be a possibility that it is a carboxylic acid. So if that's the case, so that means we must have a COOH group. Then what we can assume is we have a CH2 group, we have a COOH group. CH2 group is given here, let's say COOH group. Like I'm trying to assume because this is so for the possible logic, and there is a CH3 group we can assume because CH3 cannot be in the middle, isn't it? CH3 cannot be in the middle. CH3 has to be on the very like either one side, because like if it is in the middle, we have to have like CH2 group that can only possibly have a 2 hydrogen like carbon atom. But if it is on the last, then only we can have a CH3 group, like the carbon bonded with 3 hydrogen atom. Okay, so that's the possibility. Now, if this makes any sense, let's see our which portion is defined by this one. Let's see. We have the region between 2 to 4. So the region between 2 to 4 is defined by this value. Okay, so just a minute, let me see. Number of peaks is equal to number of peaks equals to number of hydrogen plus 1. That means hydrogen should be 1 less than the number of peaks. And if that's the case, then why are we not getting any such values? Like the other portion is defining, let's say this CH2CO, like this what makes sense, that because of this, if we consider the chart again, we have 0, 2, 4, 8, 10, 12. Okay, we have in between this, there we have a like singlet here, 12, 10, 8, 6, 4, 2. There is 0, let's say. And there we have this triplet here, and there we have this quartet here. What defines is this singlet is due to carboxylic acid. This quartet is for our this quartet, like the okay, so now I got it. So, like certain things I'm like it has to come to me like after a while, so I have to be thinking very like thoroughly. See, the number of the number of hydrogen atom here might not resemble like completely that this represents that specific group. Like what am I trying to say? See, when we are trying to find, like at first we are trying to find CH2, isn't it? Now CH2 was for like was whose environment? CH3's environment in this case. Like try to be very concerned, very focused over here. Okay, don't miss it out. We are finding, let's say this, like we have this carbon, like we are thinking we have this carbon, we don't know how many hydrogen it has. Okay, let's say initially we don't know how many hydrogen it has. We also don't need anything about it. We're thinking that we have a carbon here. And for this portion, this region, we know that this carbon's environment is a CH2 group. This carbon's environment is a CH2 group. That means what? This carbon's environment is here, which is CH2 group. That means this is the region for that carbon, not CH2. This is the peaks for its environment. Let's say this is A and this is B. Okay, this is A and this is B. We have the peak for A's environment. That means this is for, we are observing for environment. Like, why do we use this chart? For finding the environment. And how do we get the peaks value? We get the peak value for the adjacent carbon's hydrogen. So that means we are focusing on A, and A's environment is, in this case, CH2. We can find so far. This is CH2, isn't it? So far it is representing CH2. That means this is the region for A. We don't know any information about A, but we know A's environment or A's neighbor is what? CH2. A's environment is a CH2 group. That's what we know so far. Okay, I hope that's clear now. Now, for the next portion, let's say we have the CH2 group in this case. Okay, or let's say, let's initially go, instead of CH2, let's go to the singlet part. This singlet, we found that this singlet was what? Because of carboxylic acid. Okay, there is a carboxylic acid, but how is it, which atom is it bonded? We know we have 3 carbon atoms. One of them is over here, found. 2 more left. Now let's see, do we have any other information? We know that in between this region, if we get a CH2C double bond O, that means it could be one of the possibility. We have a CH2. Now we are assuming, let's say we have a C double bond O group here. Okay, that will say that, okay, it is in between this group. That will say it is in between this group. Why I'm saying that? Because try to observe that over here, what do we have? It is in between 2 and 3, specifically 2 and 3. That means 2.2 and 3, like sort of close region, isn't it? Now, if we want to find its like environment, this component's environment, specifically this component's environment, let's say, then what do we can see? We can see that over here we have a quartet. Quartet means what? CH3. That means what? This is the environment for whom? This molecule, this portion, or this entire portion? Like this entire portion's environment is which one? This portion, because we are finding the environment of that specific atom. So this carbon's environment is which one? This one. That means environment was found. Now who is the environment? We got to know the information about the environment. That means the environment is what? It has 3 hydrogen atoms. So there should be a carbon atom with 3 hydrogen atoms, which is the environment of this carbon atom. That means this is the information for whom? These carbon atoms. Why? Because we are finding these carbons' neighbors. Through neighbors, we can find ourselves. Through neighbors, we can find specific information of certain atoms. We cannot have specific information about this atom with respect to this. We have to find its information with respect to its neighbor. Okay, so that's how it goes. I know it's a bit tricky and complex, but still try to be focused, rewind the video, and try to observe it again and again. If you didn't get it, don't worry. I'm trying to explain it again. So this time I think things will be easier. Now we do know that this is a carboxylic acid already. So this is CH2 C double OH. Let's again find it out, this time with this structure drawn here. Initially, we know we have 3 like environments here. We know there will be 3 environments so far, and we do know, we found that there will be 3 carbon atoms. So okay, find 3 carbon atoms. Now going with the first one, we have what? We have like a triplet. Now remember, we are finding the environment. That means we are observing a carbon atom and we are getting information about its neighbor carbon atom, its neighboring carbon atom. Now, let's say this is me and this is my position. I'm trying to find what is my environment. I can see my neighbor carbon has 2 hydrogen atoms because of this one. Because it is a triplet, that means n-1, peak number -1 is equals to n, which is 3 minus 1 equals to 2. That means I am this environment and I am observing my environment, or my neighbor is a carbon who has 2 hydrogen atoms. So that means this is represented for me. Now, about my information, or about my neighbor's information. If this is my neighbor is like, I'm one of its neighbor, and I don't know if it has another neighbor over there or not. So that's why we're trying to find the singlet portion at first. By using, like, trying to find the singlet portion, we don't know, we have a carboxylic acid, but we don't know with which atom should it be like bonded. Like, with, is there, like, obviously there is another atom, but so far it makes sense that it is CH2. That means this carboxylic acid will be bonded with this portion. Okay, fine, we bonded it, like we make this together, carboxylic acid. We have a singlet because of this carboxylic acid. Also, see that one more carbon is left. Fine. Now, this region could be identified from the data booklet. How? Using the environment values, or the region of environment values. See, if CH3 is our like suggested or assumed structure, this is not our assumed structure. Okay, fine, then this is not going to be the one. Is this our assumed structure? Yes, it contains our assumed structure. This is CH2 and C double bond O. So that means this is our assumed structure, which is in the region of this portion. That means this quartet could be a possibility that it is defining like this particular position. That means this is my neighbor, or my neighbor is this entire one, and we are going to find the information about this entire neighbor, and its neighbor is home. Like, let's say this is some family, its neighbor is this carbon atom, and from this information we can find that this family's neighbor carbon atom has how many hydrogen atom? 4 minus 1, 3 hydrogen atom. That means this is the information for whom? Our CH2CO group, isn't it? Because that's how we were able to find the information from the data booklet. From data booklet, we are able to find this information. We are able to find this information. And we got the information for these two separate groups, isn't it? Those are like specific element or given. Now we know, or now at least I know, what is my structure, isn't it? That means initial this condition was for whose environment? Its neighboring environment, isn't it? Its environment, like the environment for the initial carbon atom. Now this carbon, we got the information, isn't it? What is this? It is CH3. That means the initial position, this triplet is for whom? This CH3's environment. This CH3's environment. That means the region from, let's say this is in between 0 and 1.7. So we can mark that the approximate value is, let's say, 1.1. Okay, it is exactly like I'm trying to calculate the average value. Let's say it starts at 0.9 over here and ends at 1.7. So I'm trying to say that 1.1 represents a complete, like, let's say this is 1.1. Okay, that means it does represent where it is positioned. So 1.1 is for whom? Because of CH3, because we're finding the environment for CH3. Okay, so 1.1 is for CH3's environment. Then we got information for, let's say, 2.2 to 3.0, isn't it, over this region. So we can mark this at 2.2. So 2.2 is for whom? We got to know that 2.2 is for this CH2CO's environment. So this is for CH2CO's environment, because we were finding at this position whose environment? This, like, its environment. And the number of peak is for whom? The environment carbon, or the adjacent carbon's hydrogen. Remember, this position is for this like this group. This position, like this value, is for this group, and the number of hydrogen, or the number of peak, is for its adjacent carbon. Okay, so I guess this will be easier for you. So let me write it down. Position value for me, however, peak number is for adjacent C, or position value, let's not give me, let's say this is for present carbon. That means the carbon which we are observing, present carbon. So position value, that means this position value is for this carbon, or this group. Okay, this position is for this group, and the number of peak represents what? its adjacent carbon's hydrogen number. Okay. Similarly goes to this one. This position is for whom? This CH3 group, and the number of peak represents its adjacent carbon's hydrogen number. Now I hope things make sense. I know I'm a bit, I did make things complex earlier, but I think now things will be easier for you. So that means this is the region for CH2OH. Finally, we have what? Something near to 12. So let's say this is 11, that means 11.8 or something. 11.8 is for whom? We do know it's for carboxylic acid. We found it out. So that means that's the molecule. So the molecular formula should be what? C3. We have 1, 2, 3, 4, 5, 6, H6 and O2. So that's the molecular formula. Got it? I hope this was a bit clear for you. Now, is there any possibility for some other portion? Let me see. Where does this question ends up? Let's see. A, B, C. Okay. Okay, so that was it. How many? Is there any groups for? Is there any possibility for ester linkage? Okay, no. Okay, so let's get back to our blackboard. So that was how we tried to solve it. Now, for this molecule, for this molecular formula we found, C3H6O2, we are supposed to find 3 possible isomers with 2 chemical environments. Okay, now we do know this was what? 3 chemical environment structure. Now they're asking us to find its isomer which should have 2 chemical environments. Pause the video and try it yourself. I know you can do it. Okay, so trust yourself, pause the video and try to make some certain molecule, change the functional group, try to make in such a way that it might or it should have 2 functional group. Okay, 3 such isomers should be present here. If you are unable to solve it, then let me help you. So initial could be an ester. So CH3, C double bond O, CH3. Try to see, we have an environment over here, another environment over here. Now you might say they are identical, but no, see, one of the CH3 is connected to this carbon, another is connected to an oxygen. That means they are not similar. So they are actually unique and different. That means we have 3 environment for them. However, there's no more hydrogen. This does not represent any environment, because to represent an environment, we need what? Hydrogen. That means only 2 hydrogen, 2 environments are here in this case. Okay, fine. Now, for this portion, we have, let's say, we can have, you completely don't need this double bond. Okay, you can have something without this double bond as well. You can have cyclic structure, anything you have, just you have to make this molecular formula. So if that's the case, let's say, let's have one such molecule as this. Is this one? This could be, but no, this cannot be one. So there is only one hydrogen, one oxygen here. And what could it be? Let it be then oxygen over here instead. So this is oxygen. There is no bond between them. This is carbon, this hydrogen. So this is one such I know this is a bit scary. You might say, like, you could have never recalled or never could have come up with this sort of structure. It's completely fine. Take your time. With like, now you got to know that you have to think out of the box. You have to think some other way. If not possible, like you can do, like you can like you can apply your creativity. You don't have to be like following the rules. You can apply your creativity. Just have a molecule with this number of molecular formula. But remember, don't give like more number of bonds. Oxygen cannot have more than 2 bonds. Carbon cannot have more than 4 bonds. Okay, remember that. Coming up with this one, so we can have this structure. We would have this structure. So that also represents. Okay, so this could be a possibility. There could be other possibilities. So I would urge you to try it by yourself. If there are other possibilities or not, try it by yourself and do post a comment. Okay, like if you get any other possibility. Okay, so these were the two chemical environments. Now we're going to talk about the structure CdCl3. CdCl3. Now what is this? You might be thinking, so far we have studied chemistry. In the periodic table, we couldn't find any component or any element naming D. Now, what element like did you come up with D? Don't worry, D is not like any new element. It's just the isotope of hydrogen. So we know what like hydrogen like could form water. This is known as the deuterium isotope. So this could also be a possibility, D2O. This is hydrogen, but since the the neutron number is different for both like each of them, deuterium has most probably one more proton than hydrogen. That's why we represent, like, to have a dissimilarity, to distinguish between them, we represent it as D2O. Now, remember, let's say if ROH is there, okay, and we placed like over here, like with it, let's say we placed D2O, deuterium, okay, then what will happen? What will happen over here is, since we have this D2O, one of the deuterium will break from here and go and form a bond with this side, like replace this hydrogen. We have what? We have 2 hydrogens, isn't it? So in deuterium also we have 2 D. Now one of the D will break and replace this hydrogen, and that hydrogen will come in place of one of the D. So that means we will have HOD. Now how HOD works? This way, HOD, like one is deuterium isotope, another is hydrogen isotope. Both are hydrogen, but they are isotope of each other. Now that means what? A hydrogen disappeared. If a hydrogen disappeared, remember in HNMR, like HNMR, we got values for only hydrogen. That means one of the group will disappear. The peaks will disappear. So absorption, which is known as actually absorption, like these peaks, the values of peaks, or these peaks are known as absorption. This absorption will disappear. Like the singlet, due to this absorption, that will disappear. That means we will get wrong information, or we won't be able to get information about this molecule. Okay, if a D2 was added. Similarly, let's say we have our COO, carboxylic acid. We again added, let's say, D2O. Like this is a reversible reaction because this is not a complete ionic reaction. This like it sort of follows our equilibrium. Similarly, this RCOOD will form and HOD will be formed. Again, the like we know like greater than 9 and less than 11, like somewhere in the region of 11, like 12, like greater than 11, less than 12, somewhere in the region there, a carboxylic acid singlet is found, isn't it? Like absorption is found. But this will disappear because of the replacement of the hydrogen atom. Okay. Now, moving on to our informations, the hydrogen in the OH group and the carboxylic acid, like as we have seen, they can be displaced by the deuterium isotope. So our absorption values will be disappeared because of the D group or D atom, deuterium atom. Okay, that's an information to be given. Now let's move on to our next example. Here, it is mentioned that A is a molecule which is a saturated alcohol. Okay, and the AM is to M+1 ratio is given as 20.4 is to 0.9. That means what? M over M+1 is given, but we know, like, we need which value? We need M+1 over M. That means just flipping the value, reciprocating it, we should get our actual value, like the required values. Now, it say that molecular ion peak M was at a value of 74. Oh, now I remember. So M represents molecular mass. Okay, so M represents molecular mass. Okay, molecular mass of, like, there, like, molecular mass of the ion. Okay, like, for example, in certain, like, while we are doing mass spectrum, we get this sort of ions. Let's say CH3 plus ion, CH3, CH2 plus, and like this sort of ion we do get. Okay, so these are species. Okay, these are species, and one of the species is having such ion, and that species mass is given 74. So this is the information that will be like handy for us in the later part. And one other information is given here is the absorption values, or HNMR absorption values. Okay. Now it starts at, let's say, 0, 2, 4, 6, 8, 10, 12, 14, 16. So in the region of 0, we have our doublet here. Then we have a singlet in between this 2's place, greater than 2. And we have a doublet here, let's say, somewhere here. Okay, so doublet here in the region of 4, singlet there. And we have, let's say, we have multiple, like, we have a, like, something multiple here, like some multiple here. Okay, so since the drawing is not good here, let me draw it clearly, and the video might end here. We'll be continuing in our like next part of the video. Okay.